Hello, my name is Madeline Allwine with Bentley Systems, and today we will be going through Workshop 2 on detention pond modeling. We are going to begin by opening an existing hydraulic model. You can browse to wherever you have your file saved and open detention ponds. Select Yes to track changes. You can close user notifications if they come up and click Zoom Extents to view the model. We're going to start by reviewing the data that is already entered for the model. We're going to start by looking at the pond properties. So we can double click on the pond, and we're going to look at the data entered in the elevation area field by pressing the ellipsis. So as you can see, the elevation area data has already been entered for us. Next, we're going to review the pond outlet structure. So we can double click on Riser to view its properties and select Edit Composite Outlet Structure. Here we can look at the properties entered for each of the elements of the pond outlet. Select Pond Outlet and click Compute to view the rating curve. You can close the user notifications, and as you can see in this pane, we can see the rating curve for the pond outlet. If we click on the Rating Table tab, we can also view the data in a rating table. Now we are ready to compute the 100-year scenario. To do this, we can select Analysis, Compute, and you can close the Calculation Executive Summary when you're done. Next, we are going to graph the flow out of the SCS area and the pond. To do this, we will select each of these elements while holding down the Control key, right-click, and select Graph. Under the Pond folder, we want to uncheck Hydraulic Grade and check Flow Total Out. For the catchment, Flow Total Out is already checked, so we can press OK. And as you can see from this graph, the flow out of the catchment and the pond look very different, and this is because the composite outlet structure controls the flow out of the pond. And to compensate for this, from about hour 13 through 24, the flow out of the pond is actually greater than the flow out of the catchment. Next, we're going to make a graph of the pond's hydraulic grade. So first we'll select the pond, right-click, and select Graph, and press OK. So now we can view the pattern in hydraulic grade versus time. Next, we will select Series Options, and we're going to add Flow Out and Volume to the graph. Here we can see that they all follow the same pattern, and that is because the hydraulic grade elevation is what drives the flow out through the pond outlet structure. Next, we'll create a color coding for the pond. To do this, we'll select View, Symbology, and expand the pond. Next, we'll right-click on Pond, select New, Color Coding. And the field that we are creating the color coding by is hydraulic grade. So we can scroll down in this list to find it. And we want to calculate the full range. Next, we'll press Initialize to get our categories for the color coding and press OK. To view how the hydraulic grade in the pond changes over time, we will select Analysis, Times to bring up the time browser, and we'll animate the pond starting at hour 11. Here we can view the rise and fall in the hydraulic grade. Close the time browser when you're done. Next, we'll create a profile of the pond, riser, and the underground pipe. To do that, we will select View, Profiles, and then select New, select from Drawing, and then click on the pond, the riser, and the underground pipe, and select this check mark when you're done. And then select Open Profile. And now we will animate this profile starting at hour 11. And we can see once again the rise and fall in hydraulic grade over time. Now the owner is ready to develop a portion of his land, and a second pond will be needed, which will be close to the first pond and at a similar elevation. To model this development, we will create a child scenario of the 100-year scenario. To do this, we will select Analysis, Scenarios, right-click on 100-year, and select New, Child Scenario. We'll name the scenario Proposed Pond. Double-click on Proposed Pond to edit its properties, and we will create a new active topology alternative by selecting New in the active topology field, and we will name the alternative Proposed Pond, and select OK. And we will also create a new hydrology alternative by selecting New, called Proposed Hydrology. We will now make Proposed Pond the current scenario by selecting it and selecting Make Current. This way, the changes that we will make will be contained in the two alternatives that we just created. Now we're ready to lay out the new catchment and pond. To model this, we will lay them out to the side of the existing catchment and pond. To do that, select the Layout tab and select Catchment, and we will draw our catchment at the upper end of the existing catchment. The size and shape doesn't matter since we'll be entering this data separately. Right-click and select Done, and click on the Select tool, and we will rename this catchment Upper Area. Now we can lay out the pond by selecting the Pond tool, and we will place it in the lower corner of the catchment we just created. Right-click and select Done, and we will name the new pond Upper Pond. Now we can enter properties for these two new elements, starting with the upper area. First, we will select an outflow element, and we will select it from the drawing. So we will click on Upper Pond, and notice that they're connected with a dashed line now. We will enter a user-defined area of 5 acres. We will leave the runoff method and loss method as they are, but we will change the area to be defined by multiple sub-areas. In the sub-areas field, click the ellipsis to edit, and click the ellipsis again in the surface description field. This will open the curve number libraries. So we can expand the curve number libraries, and because we want to model the finished situation, we will choose fully developed urban areas with vegetation established. From here, we'll select urban districts, commercial and business, and soil group B. We want this to take up the entire area of our catchment, so we will enter a percentage of 100% and select OK. And now this is filled in the sub-areas field. Finally, we will enter a time of concentration of 0.1 hours. Notice that we entered an area of 5 acres for the upper area, but this is not new area. This is actually a part of the original SCS area. So to compensate for that, we need to edit the properties of the SCS area and change the area from 20 to 15 acres. Now we're ready to edit the upper pond properties. So we can double click on upper pond. And we want to enter elevation area data. So we'll click on the ellipsis in this field and enter the following: 100.2 feet and 1.5 acres, 102.7 feet and 1.5 acres, and 105.2 feet and 2 acres. When you're done with that, you can click OK. And now it will be filled in the elevation area field. Next, we want to connect the two ponds with a culvert. And to do that, under the Layout tab, we'll select the Conduit tool. Right-click and select Pond Outlet Structure, and we're going to place this at the bottom of the upper pond. Next, we'll right-click and select Outfall, and we're going to place the outfall at the top of the lower pond. And right-click and select Done. Now we will rename each of these elements. The pond outlet we will rename to Weir. The conduit we will rename to Connector. And the outfall we will rename to Upper Outfall. Now we will enter properties for each of these elements, starting with the connector. We'll enter an entrance loss coefficient of 0.4, an exit loss coefficient of 0.4. We'll choose box as the section type. We'll enter a rise of 1 foot and a span of 2 feet, and a Manning's N of 0.012. We'll set invert start to 100.2 feet. We will change has user defined length to true and enter a length of 200 feet. Under the physical culvert category, we'll change is culvert to true. And now we need to edit the culvert head wall by choosing Edit Culvert Inlet Coefficients from the drop-down menu. And we will select Import from Library. And we will expand the first two folders and choose Rectangular Box. And then scroll down to Concrete Slope Tapered More Favorable Edges and select this option. Now we can close this window and select the culvert head wall that we just created. And for the downstream end wall definition type, we can choose Use Stop Node. Next, we'll enter the upper outfall properties. We can choose boundary condition type as boundary element. And next we'll choose the boundary element from drawing. So we'll choose select boundary element. And we'll select pond in the drawing. And we'll enter a ground elevation of 105 feet and an invert elevation of 100 feet. Next, we'll enter the Weir properties. We'll enter a ground elevation of 105.2 feet. And we will select the upstream pond from the drawing. And we'll click on Upper Pond. For Has Control Structure, we will select Yes. And we will have to edit the composite outlet control structure. In this window, we will select New Composite Outlet Structure, and we will name the new outlet structure Upper Pond Outlet. In the properties of the Upper Pond Outlet, we will select the pond from the drawing, and we will choose Upper Pond. And as the downstream element ID, we will select Pond from the drawing. Now with the Upper Pond Outlet selected, we will choose New, Weir. And in the Weir properties, as flow direction, we will choose Forward Flow Only. We will set the elevation to 103.5 feet and the V-notch angle as 90 degrees and the coefficient of discharge as 2.5. Next, we will select Upper Pond Outlet again and select New, Orifice. We will change flow direction to Forward Flow Only. We will change the orifice coefficient to 0.65, set an elevation of 100.5 feet, and set the orifice diameter to 8 inches. When you're done with that, you can close this window and choose Upper Pond Outlet as the composite outlet control structure. And now we are ready to compute the proposed pond scenario. So we will go to Analysis and select Compute. You can close the summary. Now we're going to look at the Upper Pond Outlet rating curve. And to do that, we're going to double click on Weir and select Edit Composite Outlet Structure. And here we can see the family of rating curves for the Upper Pond Outlet. Next, we're going to create a profile from the upper pond to the outfall. And to do that, we're going to select View, Profiles, New, select from Drawing, and then we're going to select the upper pond and the outfall, and click the green check when you're done. And we'll select Open Profile. And we're going to animate this profile starting at hour 11. So we can see the rise and fall in hydraulic grade. Because the two ponds are at similar elevation, water should be able to flow from the lower pond to the upper pond via the connector. So to model this, we are going to select Analysis, Scenarios, and we're going to create a new child scenario of the proposed pond. So select New, Child Scenario, and we will name this scenario Reverse Flow Allowed. We'll double click on the scenario to edit its properties, and we're going to select the physical field and select New to create a new physical alternative, and we're going to call it ICPM, or Interconnected Pond Modeling Physical, and select OK. And now we're going to select Reverse Flow Allowed, Make Current, so that the changes that we make are going to be contained within this new physical alternative. So we're going to double click on Weir to open its properties, and we're going to select Edit Composite Outlet Structure. And with Upper Pond Outlet selected, we're going to click this duplicate button to make a copy of the outlet structure. And we're going to name it Upper Pond ICPM. And the changes we're going to make to the weir is that we're going to now allow forward and reverse flow. And we're going to do the same to the orifice. And we want to make sure that the orifice diameter is still set to 8 inches. So you can close this when you're done, and we want to select Upper Pond ICPM as the composite outlet structure. Now we're ready to compute the reverse flow allowed scenario. So select Analysis, Compute, and close the summary. And we want to graph flow in the connector for the proposed pond and reverse flow allowed scenarios. So we're going to right-click on the connector and select Graph. And we want proposed pond as well as reverse flow allowed. And we're going to click OK. So as you can see, for the reverse flow allowed scenario, there is negative flow, and this represents flowing backwards through the connector from the lower pond to the upper pond. Next, we're going to reopen our Profile 2 that we created before. So we're going to select Profiles, Profile 2, and we're going to animate it starting at hour 11 again.
If you found this video helpful, please give it a like. If you want to see more such series, consider subscribing to our channel. Thank you, and see you next time.